Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to practice integration by substitution with a specific u-substitution designed for the given integral, radical x minus 2 divided by x plus 1. And our goal here is that to apply the substitution and convert this integral into one of the forms right here. Right here. All right, so either we're going to write the bottom of that as like difference of squares or sum of the squares. I don't want to give you any hint at this moment. Please move forward and watch the rest of the video to see what I'm going to do for the given integral with the given specific substitution. All right, let's get started.
All right, so let's read the question statement. We have a u substitution provided to us, u equals radical x minus 2, and the question is asking to evaluate this integral by using this substitution explicitly. So why don't we do it, but let's be careful all the way because this substitution is not one of the known substitutions, so we may need to work with the algebra of the problem carefully. All right, so we have u equals radical x minus 2. And I'm going to write this with the power x minus 2 to the power of 1/2 so that I can use the chain rule or power rule for differentiation because I need du, right? So du follows from that 1/2 x minus 2, negative 1/2, power rule for integration, and times the derivative of the inner part, which is 1, times dx. Okay? I use the power rule for differentiation here. And let's just rewrite this. So this is 1/2 radical x minus 2 dx. Okay, so because x minus 2 to the power of negative 1/2 is 1/x minus 2 to the power of plus 1/2, but that's radical, right? So radical x minus 2. All right, so let's see what's going on here. In the bottom, we have x plus 1, and x plus 1 doesn't look like u or du, so we should sort of like work through that. So to convert x plus 1 to the u version of that, I should take the square of u so that I can solve this equation for x, and I can come up with x plus 1. So what I'm trying to say is that if I take the square of this is u squared equals x minus 2. I need x plus 1, so I'm going to add 3 to both sides of the equation here. Okay, so that makes this equation to be u squared plus 3 equals x plus 1. So now I know exactly what the bottom is going to be in terms of u. Okay? So let me just rewrite this in the next slide. So I have at the top x minus 2, radical x minus 2. I have u to be equals to radical x minus 2. In fact, you can also simplify this a little bit because you also have radical x minus 2 popping in the bottom here. So this is equal to 1/2 u dx. And you can even simplify this further, that 2u times du equals dx. So now, how many things am I going to replace in the original integral? First of all, dx is going to be replaced by 2u du. X plus 1 is going to be replaced by u squared plus 3. And obviously, radical x minus 2 is going to be replaced by u. Okay, so at the top, u, because of the, let me just write it here and then carry that forward to the next slide. So let me just continue right from here. Okay, so we have radical x minus 2, which is already u. Okay, and then I have dx, and that's equal to 2u times du. Okay, all divided by x plus 1, which is u squared plus 3. Okay? So to wrap up, at the top you have 2u squared du, and at the bottom u squared plus 3. Okay, 2u squared, here we go. I'm going to continue right here. 2u squared divided by u squared plus 3 du. Okay, so this is a brand new integral to tackle with, and let's try to handle this integral first, okay? Because this is not a kind of integral that we can integrate in one shot, or this is not one of those integrals that pops in the basic integration rules. You can check this by yourself. Okay, so check this out, and this doesn't look like any of the integrals here. And the bottom of this fraction is good, which is sum of the squares, which can be written as the sum of the squares, like u squared plus radical 3 squared. But I still have u squared at the top, which looks to be a problematic term. Okay, so what I'm going to do here is that I'm going to pull 2 out first. And I'll try to simplify this fraction. I'm going to split that into 2 fractions because I may make the top look like the bottom by adding and subtracting 3. So I'm going to have a separate workout here, okay? So that is on u squared over u squared plus 3. So I'm going to write it like u squared plus 3 minus 3 divided by u squared plus 3. This is one of the algebra techniques to simplify the integrand. So I'm going to split this as this. Okay? So now I have 2 fractions. And in fact, the first fraction is just 1, right? Which is awesome for the sake of integrating the top integral, because I'm going to go back and write this as 2, 1 minus 3 over u squared plus 3 du. And now I have 2 integrals to take care of. One is the 2 du integral, and the other one is maybe 6, because 2 times 3 is 6, du over u squared plus 3. Well, since I'm done with this, with working with this fraction here, I'm going to erase that, okay? To save space. All right, so this integral looks like one of the integrals involving inverse trig functions because I can rewrite this as 6 du over u squared plus radical 3 squared. Okay. And this is one of those integrals that we had in the beginning, integrals involving inverse trig functions, and this is almost like the second kind here, second formula. So this is 1 over a arctan u over a. So a is the number you work with, u is the variable you work with, and it's 1 over a arctan u over a. Okay, here we go. So let's just do everything in one shot. So 6. So let me just write 6 here. 1 over radical 3 arc tan u over radical 3. This is the second integral. And then I have 2 times u here. That's how you integrate 2 times du. All right. So I'm going to put an integrating constant. But remember, the original integral was in x, so I'm going to go back to the x variable here. So I'm going to replace this u by radical x minus 2, as well as this u in arctan. All right, so that is also radical x minus 2 at the top. Okay, I think that is taking care of everything, and we're done with integration. That means we're done finding or evaluating this integral provided to us with the corresponding u-substitution. Again, this is a very non-trivial u-substitution, but it worked fine, and eventually we had to use adding and subtracting type manipulation, algebraic manipulation, to be able to handle the integral here, the integral right here, okay? Right, so eventually we put everything in the form of like arctan type integral, arctan type final outputs, right? So this is the end of the video. Thanks for watching. I'll see you in another video. Bye.